Question 1, Part E. Use integration by parts to evaluate the integral of x squared times sin x dx from x equals 0 to x equals pi over 2. By inspection, an integrand of the form x squared times sin x dx requires two applications of integration by parts, and with each application, the power of x is reduced by 1. So this term here, multiplying the sin x dx, so x squared, after the first application becomes x to the power of 1, and after the second application becomes x to the power of 0, which is equivalent to 1. Now recall the integration by parts formula. That is, the integral of u dv is equal to uv minus the integral of v du. Now because we're focusing on the term involving x squared eventually disappearing or eventually becoming 1, we're going to let u equal x squared because we want to differentiate that to reduce its power by 1. So differentiating u with respect to x, we get du is equal to 2x dx. The power of x here is now 1. And let dv equal sin x dx, and by integration, v is equal to negative cos x. Hence, the integral of x squared times sin x dx is equal to negative x squared times cos x minus the integral of negative 2x cos x dx. This is our first application of integration by parts. Now we have a double negative here, and the 2 here that's multiplying the x can come out in front of the integral. So we get negative x squared times cos x plus 2 times the integral of x cos x dx. And we'll call this equation number 1. Now we need to focus on this integral here, the integral of x cos x dx. And we're going to use integration by parts again to find that integral. So using the integration by parts formula, but I've changed the variable, so the integral of w dz, because I've used u and v already, is equal to wz minus the integral of z dw. And in this case, I'm going to let w equal x, so dw is equal to dx, and I'm going to let dz equal cos x dx, so by integration, z is equal to sin x. Hence, the integral of x cos x dx, using integration by parts, is equal to x sin x minus the integral of sin x dx. And the integral of sin x dx is trivial, it's cos x. So we get x sin x plus cos x. So from equation number 1, because we've now worked out this integral, we can combine our results. The integral of x squared sin x dx from x equals 0 to x equals pi over 2 is equal to negative x squared cos x plus 2. So this 2 here is this 2 here times x sin x plus cos x in brackets from x equals 0 to x equals pi over 2. So applying the limits of integration, noting that cos pi over 2 is equal to 0, sine pi over 2 is equal to 1, cos 0 is equal to 1, and sine 0 is equal to 0, we end up with this result, pi minus 2.